The Fly-Morton characterized wearable biometric percussion skeletronic is lyophone biomechanical mechatronic full-body biomedic extophoresis bionic modulated harmonic sonic magnet transducer powered armor air engine pneumatic thermoelectric thermoplastic polyurethane electromagnet static electrolysis powered buoyancy armor generator electron beam vacuum inductance helium energy buoyant envelope vibranium piezoelectric pyroelectric thermoelectric titanium-powered accelerator body armor airship robot suit machine manned powered buoyancy body armor flight suit, subject not limiting to additional system or structure Fly-Morton characterized wearable mechatronic power armor powered buoyancy exoframe titanium envelope buoyant armor enclosures. Fly-Morton characterized wearable exoskeleton human biometric brainwaves controls facility manned humanoid transformer airship. Fly-Morton characterized wearable transducer helium power buoyant armor orthotic rest manned core. Fly-Morton characterized wearable biometric biomechanical titanium percussion envelope power armor enclosures. Fly-Morton characterized wearable exoskeleton exoframe functions as an electric actuator linear dual action functional likenesses is a pneumatic motor, air motor, compressed air engine component of a machine that is characterized wearable biomechanical responsible for biometric range and size designed to corresponding alongside the shape and joints or segments of the human body user for moving and controlling external biomechanical metallic additional system or structure operates as an helium buoyancy envelope titanium strengths maintains the biometric coordinated shape system enclosures. Fly-Morton characterized wearable exoskeleton envelope actuator requires a control signal and a source of energy. The control signal is relatively low electric energy, voltage or current. The mechatronic exoskeleton robotic system is not limited to neuron motor controls. The Fly-Morton characterized wearable mechatronic biomechanical robot suit machine system is not limited to software-based controls of the mobility machine suit exoskeleton system. The Fly-Morton characterized wearable mechatronic exoskeleton or exoskeletronic buoyancy type armor operates likenesses and in stepper motoring. This includes pneumatic air compression. The Fly-Morton characterized wearable exoframe engine does mechanical work by expanding compressed air. The Fly-Morton characterized wearable pneumatic exoskeleton motoring linearly converts the compressed air energy to mechanical work through linear or rotary motion. Linear motion can come from either or pistoning actuator linear while rotary motion is supplied by either a vacuum or dispatching type or air turbine type motor. Exoskeleton engine serves up to more than several hundred horsepower rotary vane motor, uses electrical kinetic energy or air to produce rotational motion to the thermoprotection electron beam magnetic vacuum shaft. The rotating element is a slotted rotor which is mounted on a drive shaft. Each slot of the rotor is fitted with a freely sliding rectangular vane. The exoframe vanes are extended to the housing walls using springs, driven action, or air pressure. Air is pumped throughout the pneumatic exoskeleton cylinder input which pushes on the vanes creating the rotational motion of the central shaft. Rotation speeds can vary between 100 and 160,000 revolutions per minute depending on several factors which include the amount of gas pressure at the exoskeleton core uses electrical energy that provides strength of the magnetic field it generates, a charge to the mechanism used to regulate the gas, the biometric biomechanical sealed motor cylinder chamber and exerts pressure against the vanes of a rotor. This causes the rotor to turn at high speed. The exoskeleton submechanism core varies from linear action. Plunger type actuators operates as an exoskeleton. The Fly-Morton core operates as in pivoted armature actuators and rocker actuators embedded. The Fly-Morton characterized as in wearable mechatronic exoskeleton extended valve can use a two-port of the Fly-Morton biomechanical exoskeleton core design are used to regulate a flow or connections inputs to three or more external port coordinate alongside design when switched flows between ports. The Flymorton characterized wearable mechatronic pneumatic exoskeleton biometric biomechanical transducer enclosures functional all-in-one likenesses as an actuator linear gas cylinder bomb rotary heat exchanger transformer core metallic bond, MFD. Solenoid hold and sensory extended together not limiting additional structure or Flymorton mechatronic machine biometric biomechanical alternative structure human facility modular core. The Flymorton characterized wearable airship exoskeleton core operates an air engine flywheel requires a great deal of torque to start the engine. Reduction gears are used. Reduction gears create high torque levels with the lower amounts of energy input. These reduction gears allow for sufficient torque to be generated by the engine flywheel while it is engaged by the pinion gear of the air-motorized Flymorton exoskeleton air starter airship Flymorton characterized wearable armor buoyancy equipped with an electron beam thruster powered the energy fuel cells of hydrogen combustion. However, the Flymorton characterized wearable machine suit may be considered as an energy hydrogen fuel cell generator, operates within electrolysis having additional operations as in Peltier effect envelope armor enclosures, whereas energy fuel operates within liquid hydrogen converts into ICE mechatronic system subject not excluding its system vacuum potentials. When converting oxygen into liquid density to accommodate loss of liquid density energy conversion or aforementioned it may therefore be associated with energy alongside the electron beam. Mechatronic thermocompression cryogenesis. The Flymorton characterized wearable biomechanical mechatronic exoframe core electron beam produced by acoustic supercapacitors tubes whereas therefore are 6 individually are 6000 W in addition acoustically driven by an ultrasonic modular speeds at 767 meters per second that is used to duplicate the 36,000 W supercapacitor electrode emitter ARC forces 767 times emission time frame at 00.50 per/s reciprocating between 22 mm per/s without excluding its additional structure likenesses of a piston kit however subject to supercapacitor shaft electromagnetically reciprocating a plasma piston foot within structure likeness of piston actions to spark plugs within engines that accommodate combustion driving force. However the distance of the surface when reciprocating is at 22 mm for the piston to meet its limitation. Besides that the combustible liquid energy cells flows from the miniature cylinders into an enlarged harmonic sonic Peltier effect vacuum bladed tube cooler oxygen or particle displacement impeller oxygen converter liquid density gas cylinder sampler reciprocating bomb combustion bleeder forces throughout the rotary heat exchanger dispatching. The cost for a fully operational machine in as little under $4,000 self-balancing self-suspension buoyant suit self-propelled as to levitate against the Earth's gravity autopilot flight navigation cognitive machine consciousness auto-return neuron brainwaves synchronization or controls telechatbot auto biometric sizer sensory emotion chip multiple atomic memory slots and ROM or unlimited storage. Power lift power leg cranker when switching between alternate leg when running, self-recharge etc. Head mount display R vision microm vision tactile sensory proximity sensory gravity sensory thruster solenoid hold levitation fixed position area of fraction tractor beam fraction of area sensory cool or dissipation of heat sensory. The articulated full-body buoyant system concept ITS muscle spindles are simple as electromagnetic in exchange of solenoid rod. Solenoid steel cable alongside miniature thermoplastic liquid tubes from end to end of segments area of fraction no loose wiring. Solenoid actuator metallic bond by electric charge only electrical solenoid metallic thermoelectric tube liquid fuel dispenser by heat activated only. Solenoid rod manipulation of USB HDMI ECT electrode input pin out connections only whenever configuring additional structures or alternative structure locking activates puppeteering between each biometric biomechanical envelope armor segment all armor level layers fill with helium within shaft. In layman's terms ITS a wearable robotic metallic airship, blimp. My invention of Fly-Morton Buoyant Fingering Segment Part is characterized wearable automated system human finger manipulation. Fly-Morton powered river buoyancy fingering enables holding or tightening whenever handling and releasing an object. Modular powered electromagnetic electrical inductor buoyancy coil line closed within a central iron mesh core structure. Electromagnetic coil fingering structure separated by electromagnetic coil scissoring structure needing currents to establish a charge that covers electrical energy into a mechanical pushing or pulling force or motion as to lift. Scissoring fingering drawer guide or slide. The force and speed and movement is determined by the strength of the magnetic flux generated within the electromagnetic coil. Fingering buoyancy structure emits a beam electromagnetic radiation within proximity sensory for changes within the field or return signal. This enables the fingering to detect the presence of the localized object within vector of the field without any physical contact. Armor specification material polycrystalline ferrite, polyurethane rubber mixed carbon fiber mesh mixed with liquid method or approach vitriol electrolyte sulfuric acid phosphate powder compounds. Pyroelectric energy crystal cell compounds mixed with metal powder compounds. Iron 325 97.7% powder particle compound. Iron 100 powder particle compound. Sodium bicarbonate crystalline powder compound mixed with metal or fiber. Deform electrical wire titanium mesh. Deform graphite wire mesh mixed glass. Deform wire aluminum wire mesh mixed glass mixed with deform sewing thread Dyneema mesh mixed glass. Deform sewing thread alpaca mesh mixed glass. Deform wire silicon mesh mixed glass. Deform sewing thread Dyneema mesh mixed glass. Extensions of the user's mind or body are common to wearable as with bionics, biomechanical, biomechatronic mandav drone suit machine computing, ambient intelligence and ubiquitous computing research communities. These include power management and heat dissipation, software, architectures, wireless and personal area networks, and data management, all of which are essential for overall data quality and trust in the wearable. Fly-Morton provide manned amplification to levitate, as to fly, aerial dynamically mechanically clone movement, biomechanical cloning movements, provide manned amplified night vision, provide manned amplification ultrasounding vision, ultrasonic sounding, provide manned amplified visual systems, provide manned amplification telescope vision, provide manned amplification binocular vision, provide manned amplification computing, provide manned amplification ambient intelligence and ubiquitous manned drone computing, provide manned amplification wearable full-body bionic armor suit, Fly-Morton display structural full-body manned amplification transparency manipulator prospectively. The electric wearable Fly-Morton full-body armor is a simpler, more easily recharged, and otherwise mostly superior version than the conventional jetpack. Flying is performed by holding down push-button finger recognition jump key. The electric Fly-Morton wearable is not limited to a maximum flying height of 185 meters, blocks, above the bedrock layer. For comparison, the normal is limited to 245 meters above bedrock. It also has a hover mode, which can be toggled by pressing the FM key while in use, holding down the jump key. In hover mode, holding the jump key will make the user ascend slowly, and will automatically slow the user's fall to a similar speed. The electric Fly-Morton wearable hover mode is superior to that of the regular jetpack, as the regular jetpack cannot ascend while in hover mode. 13-axis gyro stabilization. 13-axis gyroscopes measure rotation rate around 13 and yaw. Roll, rotation around the front to back axis pitch, rotation around the side to side axis yaw, rotation around the vertical axis. Gyros keep giving non-zero readings as long as the rotation continues. Fly-Morton gravitation of the motor can be in a fixed position. The motor simultaneously spins about one axis and is capable of oscillating about the other axis, and, thus, except for its inherent resistance due to motor spin, it is free to turn in any direction about the fixed point. Its gyroscopes also have mechanical equivalents as substituted for one of being pivotally mounted in gimbals. A control moment gyroscope. OS, Windows 7. Windows base, compatibility. Body dynamics. Neuron control / walking, grasping, recognition control / sensors. Inertial, 13-axis, plus 180 degree, roll / yaw, plus 90 degree, pitch, module, optional, X2, 4 sensors in each foot. Computer. CPU, AMD E2 1800 processor dual-core 1.7 GHz RAM, 16 GB DDR-RAM. Storage. 320 TB SSD. Wireless. 802.11b/G/N. External interfaces. USB 2.0x2, Ethernet 10/100/1000 base T USB 3.0x2, HDMI X1. Interfaces. Speaker, X1, full body layer. Microphone, X1, full body layer in vision camera, 24. Vision camera. Logitech C905/HD 1600 by 1200 px. Battery. Operating duration, unlimited. Charging time, NA. 600 fps vision processing. Weight. 55 kilograms pounds, equals 121.254 pounds. Height 6.0 feet cm. Width 48 lower leg 20. Upper legs 17 upper arms 15 lower. Arm 9 waist equals 48 30. 1/8 head. Sensor 13-axis, plus minus 180 C roll / yaw, plus minus 90 C pitch. Wireless, 802.11b/G/N. External interface, US 2.0x2. Ethernet 10/100/1000 base TS 3.0x2, HDMI X1 speaker. Armor layer microphone, armor layer. Vision camera, 6 Logitech C905, HD 1600 by 1200 pixel. Operation hour unlimited O/Windows 7/